Hey, what's up, everybody? It's your boy back again with another math video. That's pretty exciting. It's like 7 a.m. right now. I guess that's not really relevant to anything. Uh, if anything, that might sound like a flex, but that's not really a flex either. All right, let's just do this. We're going to move on right about now. We're going to move backwards with reciprocal functions. So what's going to happen in this next lesson is that we're going to move in the opposite direction. So what we've been doing previously is you've been presented with either a straight line, a linear function, or a parabola, a quadratic function, and you were asked to sketch the reciprocal function and maybe get some characteristics of your new graph. This time out, we're going to be given the reciprocal function, and we are going to determine the original equation. And the best way to do that is to sketch the reciprocal first. You're really sketching the reciprocal of the reciprocal, which is going back to your original linear or parabola graph. So we're about to do that in a second, okay? But first of all, let's just take a look at some review from grade 10. Way back a couple of years ago in your numbers 10 class, you spent a lot of time doing linear functions, and I just want to review some things with you. Right here, I have a linear graph drawn, and the y-intercept here is supposed to be 3, by the way, all right? This is supposed to be a little bit more accurate here. And then you can see that there's a point here at 4, 1, another point at 2, 2. I'm just putting those points in because I don't have a grid here. We have 3 different ways to write an equation. I'll just stick with the 2 most popular ways of doing this. One way is you could write it in slope-intercept form, which means you put the slope in front of x, and then you put the y-intercept at the end. The y-intercept is a positive 3, so I can put that there. And then as far as the slope goes, okay, well, first of all, you have to say this is a negative slope because of the way the line is tilted. All right, so you move up and to the left, up and to the left. That would be a negative slope. And then we do the rise over run. So you can pick any 2 points here, and you can see that you go up 1 over 2. So the rise is 1 and the run is 2, and this is one way of writing your linear equation. Probably the most popular way, the way you see it written most of the time in slope-intercept form. There's an alternate way of writing the equation of a line as well. If you do not have the y-intercept, or if the y-intercept is like a decimal number and you don't know what it is, there's another way of writing it as well. And this is referred to as point slope form or slope point form. I can't actually remember, but I definitely remember how to do this. So what you would do is you would write it in this form right here, m being the slope. Sorry. That wasn't supposed to happen either. Okay, this is what happens when you make math videos at 7 a.m. Once again, not a flex at all. Nobody's going to be impressed by that. But anyway, I'm giving a point here as x1, y1. It didn't have to be that point 4, 1. It could be any point on the graph. So you could have your answer expressed in many different ways. But if I put in my y1 and my x1, I have that much. And then my y and x stay in the formula, in the equation, and then I have to find the slope, which I already found the previous equation, which was -1/2, and you could write your equation in this form instead. Now, if you were to take the second form and multiply through the brackets and all that sort of thing, you would arrive at the previous equation. So either form is acceptable, and you would do the first form, the slope-intercept form, if you knew what the y-intercept was. And if you don't know what the y-intercept is, you just have some random point on the graph, you may want to go with the second form. So moving along right here, okay, this is not a linear equation, but it's the reciprocal of a linear. How do I know? Well, one way is that there's one vertical asymptote. But even if you didn't recognize what type of graph the reciprocal function is, you can just start plotting points. So normally what you would do is you would take an x-intercept and turn it into a vertical asymptote. Well, here, I'll take the vertical asymptote and turn it into an x-intercept. And then you have to be given at least one other point on the graph. In this case, you're given 0 and 0.25. If you get the reciprocal of that y value, 1 divided by 0.25, it'll give you a 4. So we know that this point 0.25 is really 0.4. You can write it in here, but it's pretty clear of what it is, so there's no need to write that. And then we don't really have any other specific points, except the invariant points are when y is 1 and when y is -1. And then you can see that all these points form a straight line, so I can just make a line that goes through all this right here, and that is my original f of x graph. Okay, my original function is a linear function, and now I can write the equation of this. So because I have the y-intercept, okay, I can write it in y-intercept slope form. So I would say that the y-intercept is a positive 4. The slope is also positive because you go up and to the right. And then what is the slope? Well, you can take any 2 points and do rise over run. So what I can do is I can say, okay, starting at this y-intercept, I go up 2 over 1, up 2 over 1. So the slope is 2 over 1, positive 2 over 1, and of course that's really just 2. So we have our equation written like that. And again, you could write it in the other form if you chose to. Okay, moving along to a parabola. How do I know this is a parabola? Well, basically because it has 2 vertical asymptotes. So therefore, the original function has 2 x-intercepts. Let's do that first. Let's change the vertical asymptotes back to x-intercepts at -1 and at +3. And then let's pick some other points on the graph. Well, once again, okay, we have 1 point given to us, the 0,01.67. If you get the reciprocal of this number, 1 divided by that, you're going to get 6. So that point really is up here at 6. Notice when we go from our original to our new point, or vice versa, we don't move left or right, we just move up or down. And now that I have those points, what I can do is I can put in my invariant points of y is equal to -1 and y is equal to +1. And remember, those are the y values, the invariant points where the original graph and the new graph intersect. And you can see that this is going to be a parabola that turns upside down. That is a rough sketch of the graph right there. So we have this point of 0,6. Now getting the equation of this is very familiar because you just did it with polynomials. So we can write it in factored form. So we can say, okay, the 2 x-intercepts are -1, so the factor is x plus 1, and +3, the factor is x minus 3, and we'll solve for the vertical stretch factor of a. So we have a point on our graph of 0,6. That's the easiest one to use. So I'll put in 6 for y and 0 for x, and then I'm going to simplify. I'm going to do the order of operations here, and you can see that through this calculation right here, a is equal to -2. So then we go back to our, oh, not that one, sorry. Go back to our original equation and put in -2 for our a stretch factor, and then we have completed. Okay, you can multiply out this and put it in descending order if you wish, but that's extra work that isn't necessary.